Hello, I'm just going to talk you through the respirometer really quickly. And remember, once I've done this, find your past paper questions and check that you can answer them in accordance with the mark scheme. So here we go. A respirometer can be used to calculate the oxygen uptake of an organism, or it can calculate the carbon dioxide production of an organism. So here we have a very simple respirometer. And here we have, you can see there's very thin capillary tubing here, and inside that capillary tubing we have a little blob there of coloured liquid. And when you set up your respirometer, this tap is open and you allow the respirometer to equilibrate, so you let it sit at room temperature for 10 minutes and then you close the tap and you begin your experiment. So inside the respirometer there's a mesh grid, and sitting on the mesh grid you will have your respiring organism. That could be wood lice or it could be respiring seeds. So remember, when seeds are in the ground they do not photosynthesize. When they start to germinate they respire. So those are the living respiring organisms sitting on that little mesh platform. And then at the bottom of the respirometer, you will either have potassium hydroxide or you will have water, but you will not have both at the same time. So if you want to calculate the oxygen uptake of the wood lice, what do? You add potassium hydroxide to the bottom of the respirometer. And what happens is the little creatures, they use oxygen from the air. So in here we've got air, down here all of this contains air, and the little creatures, they will use oxygen from that air. They will be respiring, so they will produce carbon dioxide, but the carbon dioxide does not go into the air. The carbon dioxide is absorbed by that potassium hydroxide, and that means that they use oxygen, they produce carbon dioxide, but it goes into the fluid. So because oxygen has been taken out of the air, the pressure falls in the respirometer. And then the coloured liquid, it moves this way to take the place of the oxygen that has been absorbed by the wood lice. So if you want to work out then oxygen uptake, the distance the coloured liquid moves indicates how much oxygen has been used in respiration. So the respirometer then can also be used to work out how much carbon dioxide is produced. So first of all, to do this, you have to do this experiment first. So maybe you ran this for 30 minutes. So then you would reset the respirometer, and instead of having potassium hydroxide, you would have the same volume of water in the bottom of that boiling tube. You would then leave it for 30 minutes, exactly the same length of time, and you would keep the respirometer at the same temperature. So let me explain. You see, if this bubble did not move, that would mean the carbon dioxide that was being produced, which would push it this way, would be equal to the oxygen that is being used that would pull it this way. So if the bubble does not move, the carbon dioxide produced is equal to the oxygen that is consumed. And you see, if the bubble moves to the left, that means that more oxygen is being used than carbon dioxide is being produced. You see, if the bubble moves to the right, that would mean more carbon dioxide is being produced than oxygen is being used. So when you have carried out the experiment the 2 times, you can use this equation here to work out oxygen used or carbon dioxide produced. You just rearranged it. So the distance that the bubble moves the second time is equal to the oxygen that is used. That would pull the bubble this way, minus the carbon dioxide that has been produced. So you just rearrange that equation to either work out the CO2 produced or the oxygen used. But remember, you get the oxygen used from the first time that you did the experiment for 30 minutes. And you can then work out the RQ value from these things. So the RQ value is the carbon dioxide produced divided by the oxygen that is used. So that's a very simple take on the respirometer. Now, whenever you use the respirometer, certain things need to be controlled. So one of those things is the temperature. So you can put the respirometer into a water bath. And it's really important to control the temperature, because temperature, if it goes up, can change the rate of respiration. Respiration increases with temperature. And another thing is, if it is very warm in the room, the gases inside that respirometer will expand and the bubble will move because the gases have expanded, not because carbon dioxide has been produced. So you need to keep the temperature constant. Then every time you use the respirometer, you would need to use the same organisms, and that would ensure that they have the same metabolic rate and their age would be the same. You need to leave the respirometer then every time you do it for the same amount of time. And this has come up a couple of times in past papers. If you're using germinating peas, make sure that you cover the respirometer in tin foil, so that stops light getting to the germinating peas, which will stop them photosynthesizing, because you do just want to investigate respiration. If you are asked to calculate the rate of respiration, it is the oxygen used, the volume of oxygen used in respiration, divided by the time that it took for that oxygen to be used. Or if you're using a respirometer, it could be the distance that the bubble moves when there's potassium hydroxide in the respirometer, divided by the time that it took for that bubble to move. Now, in your paper, you could be asked about any respirometer. So here's one that you find in the SEA book, and you just apply the principles that you know. So here we have an airtight bung, and then just above that, we've got the living material. So that could be the woodlice or the germinating peas. And this is a straight line, but that actually should be a mesh. And then we have glass here. And then we have a bit of flexible rubber tubing, which is quite strange here. So in the bottom of this, in the U bit here, we've actually got potassium hydroxide, which has been coloured. And then we have a scale here. So if we think about this, as the peas respire, they will take oxygen out of this air, which will cause that coloured potassium hydroxide to move up here, and you can tell the distance by using the scale. As they respire, they produce carbon dioxide. The carbon dioxide but is absorbed by that potassium hydroxide, so it does not cause the potassium hydroxide to move, because the carbon dioxide doesn't increase the volume of air in that glass, because it is absorbed by the potassium hydroxide. So what's going on here? We've got this flexible rubber tubing and we've got a glass tube. And very basically, that is just a levelling arm. You squeeze this and you push this down, and that helps to reset the experiment. So you would squeeze on this, and that will put the potassium hydroxide back down here so that it is on the scale again, and you can begin the experiment. So if the liquid moves then up in this setup here, so I'm using these words here, so if the liquid moves up, that means more oxygen is used and carbon dioxide is produced. And if the liquid were to move down, that would mean that more carbon dioxide is being produced than oxygen is being used. Now I just want to talk for a little second then about RQ values. So remember that the RQ value for carbohydrates, so glucose, things like that, is 1. The RQ values for lipids are 0.7, protein 0.9. And if you got an RQ value of 0.85 from an organism, that would suggest that the organism is using both carbohydrates and lipids. Now you might think, well, why does that not mean it's using protein? Organisms only use protein if they're absolutely starving. So if you get an RQ value which is greater than 1, that suggests that both anaerobic and aerobic respiration are occurring at the same time. It does not suggest that the organism is just respiring anaerobically. It suggests that anaerobic and aerobic respiration are happening at the same time.